What's up once again, people? What do you say we have ourselves a year-end recap? And I don't mean going through all the events that happened this past year and talking about it or anything like that. I'm talking about literally doing a recap. So you may have seen this power supply that I talked about in TEF number 124, where we took a look at the this Dell Optiplex 790 power supply that had failed, and we determined that some of the capacitors had gone leaky and or had dried up. I talked about how I had replaced some of the caps in here previously to keep it going, but at the age that it's at and how long it's been in use, I figured it'd be best to just replace all of the capacitors that were inside this power supply, and that way I can keep it either as a backup or put it back in the machine to use, because I did buy a replacement power supply that also works in that machine. And so, yeah, I guess I have the option to do either once this is working again. I also ordered the replacement fuse. And so I have everything we need to be able to get this power supply freshened up and working again. And so I've got this bag of stuff here that I've ordered on DigiKey, and all the capacitors that I need for this should be in here. So I just got to go through all this stuff here. Yep, and find what I need for this. I'll set it aside, and then we'll get right to work. All right, so this pile here should have everything that we need to replace all the caps in that power supply. There may be a few others in here that I order for other things, and I'll just have to separate those out once I get to them. But as you can see, there's a lot of caps here. This power supply is definitely not going to take all of these capacitors. But usually when I order this sort of thing, like if I say I need like 2 of these, I'll end up ordering just the 10 to get the price break. And then if I don't use it for this, I'll keep it around and use it for something else. I'm eventually bound to need a similar value or whatever, or I can use it for testing things. So yeah, let's move all these out of the way here. And what I did in order to keep track of which capacitor went where and all that, because if you take a look at this power supply, you can see that there are no electrolytics populated on it anywhere. So I decided to just pop everything off, and that way I could get what each capacitor's value was supposed to be. And then I went on DigiKey and search for a similar capacitor. And one thing that's happened since the chip shortage and all this stuff has been going on is that sometimes trying to find the capacitors you want on DigiKey has become kind of you kind of have some slim pickings. Like you don't always find exactly what you want, but you might find something similar. So I kind of just had to go through and find what I could use. It's gotten better. It was pretty bad at one point. I could barely find anything that I needed, but I put everything in here that we're going to need. So actually I made this map here of where all the parts go on the board. So you can see there I've got all these capacitors labeled as to what their values are and where they fit on the board. So that way it's easy to put everything back. And there were 2 sort of little daughter boards inside of that were mounted on this the main board. So I took those off so that I could also remove the capacitors from those as well, because otherwise it was going to be kind of difficult and a lot more difficult to install than to remove them. But this will make it easy. So here's one of them. This is the one that goes over here, but it goes in this direction. So you can see how trying to have access to it there with this heatsink in the way is going to be a little problematic. So that's that one. I've got the other board in here. So you can see no capacitors on that either. This little board actually fits inside this little valley in here. So you can see where the holes for the pins are right there. And when I was removing this, I didn't realize that there was another 3 pins over here on this side. So this board fits in there something like that. And so I had removed the solder from all the pins over here, and I could not figure out why I didn't want to release until I realized that there was 3 other pins right there. So once I did all that, then it just easily came right out. The one capacitor that's going to be a little difficult to get to is one that's right down in there, right on the side of this mounting tab there for the heatsink. But I didn't want to remove this heatsink just because I would have to desolder the MOSFET that's right there, the rectifier, some other device. I don't know if it's a diode or I think that's a diode right there. So I think I should be able to find a way to maneuver it to get it back in there. And then also the other capacitor that goes in here was the big one. That was the really high voltage capacitor. So I should be able to just kind of stick that in through here and drop it in there. I do have to clean the surface off there a little bit. You can see that there's still like electrolyte residue on the board. So I'll clean that up. And I did get the fuse here, the proper fuse, and that was a fast blow 6.3 amp fuse. And it kind of darkened the board right here. I don't know how well that's going to clean up, but I'm not too worried about it right there, like if it's conductive or anything like that, because the actual pins are like opposite sides right here. The fuse just kind of like blew out the bottom in like both of these directions. So yeah, I'll clean that up a bit, but if it stays kind of dark, I'm not too worried about it. Other than that, I mean, this should be fairly straightforward. It should just be a matter of populating everything back in and then giving it a test and see if I didn't make things worse. So, move all this stuff here out of the way. Got a little baggie in here where I kept all the old capacitors. Maybe just for fun, we'll go through some of these and see if what kind of values we're getting from them. Because it's not like I went through and tested them all or anything. I just doing like a blanket like sweep and replacing everything. So, what else we got here? Oh, I got some. These were capacitors that I already had on hand, so I decided to just use these from my stock. And that's it. We should have I thought we had. Oh yeah, all the screws are inside the baggie here with the capacitors. So that's pretty much what we're dealing with. So let's go ahead and get started. Nothing to investigate really. It's all just going to be a matter of determining what goes where. All right, so this one here, it's obvious where it goes because this is the only one that I only bought like one of because not like I need these all the time or anything like that. And usually they're never like the same exact value. They're always something different and they're like different diameters and sizes. So just one of those was fine. Let's see. What do we have here? We have 100 microfarad, 16 volts. Where do we have a 100 microfarad, 16 volt cap? Ah, right there. So we need one for, not that board, one for, oh yeah, that board. So we need one for this board. I'm just going to put that there. And then we have 33 microfarad, 35 volts. Okay, that is not for this, so that's for a different project. So yeah, a lot of that stuff was things that I ordered for other projects as well. I've mentioned before that I like to just like buy a bunch of stuff at once and just have everything ready so that as I take on or as I start tackling some of the projects that I have like pending around here, at least I have the parts on hand. This is a 2200 microfarad 10 volt. I think this was one of here. Yeah, right there. It only had one of those. And then we also have two 2200 microfarad 16 volt ones. So I should have those around here somewhere. So yeah, I'm just going to go through here, find everything, put it where it's supposed to go. And then that'll make it easy to just pick up and solder onto the board that needs it. So I'll just continue with that and we'll be right back. All right, so there we go. I got all the caps here that I need laid out according to where they go on these boards. So we could easily just start by populating the small board here first. That's going to be the easiest. And these do sit like flat on the board like this, so I'm going to have to bend these pins. So I'm just going to use this here real quick just to support it right there. Bend them down. And these can go in like that. And I'm just going to bend the leads out a little bit right there just to hold them in. And once I've got those two in place, then I can solder them in and like align it to where I want it to stay. Touch up the solder there so that it softens up enough for it to be repositioned. And then I'll, once it's all like soldered in place, then I'll trim the leads. So we got the first capacitor in there and then the second one. Oh, I also want to make sure that I'm bending them down in the proper orientation depending on which side the negative goes to, and these are indicated here by these like black stripes. So this one goes in like that, and there we go. It's looking pretty good. Not that there's much to it or anything. Oh, actually the pad on this one came detached from the board. Yeah, you can see that right there. When I push the lead through, it pushed this out a bit, so I'm going to have to be careful with that. And maybe I'll even scrape off a little bit of material right there, some of that solder mesh, so that I get solder to flow up a little bit more. And that's with the pin stuck through there. So yeah, I'm going to have to touch that up a bit there once I get to it, but it should be fine. So then this board here just has the 3 caps. Now something I want to try here, I've never tried this before. But instead of putting in all these capacitors one by one, I'm actually thinking that if I just kind of like drop them in there and sprinkle them, that they'll all automatically just sort of like populate themselves and put themselves in the places they're supposed to go. So let's see if that works. I'm just going to like sprinkle these on like that. Poof! Well, holy crap, that actually worked. All the capacitors are on the board and I didn't have to do anything. No, I'm just kidding, people. This wouldn't actually work. Capacitors don't just automatically install themselves into boards. So, I mean, everything was pretty uneventful. It was just a matter of putting the capacitors in their proper locations. The only one that was a bit of a hassle was the one that's deep in there, in that corner. And so what I ended up doing for that, because I really wanted to avoid removing that heatsink, is first of all, I made sure that the pin spacing on the two leads was just the right size to be able to fit into those holes with just like, sticking it in there or without having to like pinch the pins together or spread them out or anything. So that once I was pretty confident that it was going to just slide right in, I just sort of dropped it in there and used the tweezers in here to kind of like guide it. The first pin that I stuck in was the positive, because once the positive pin was in, then all I had to do was just kind of rotate the body of the capacitor to try to get the negative to align with its the hole that it was supposed to go in. And so I fiddled with that for a few minutes in there. It would like go one way, it would swing the opposite direction, it would like overshoot the hole until I finally got it to like drop into the hole for the negative. And after that, I was pretty much home safe there, so I was able to just pull the rest of it out and bend the leads out. So everything here is ready to solder. And the only thing I haven't put on here yet is the fuse, although I did clean up the location for that. So that cleaned up pretty well. It definitely looks much better. And now, because there was a little bit of a mark left there, that actually looks like a little smiling baby. So it's a happy little boy. So all the capacitors and fuse are on this board now. All the capacitors have been populated into these two small boards. I've got the soldering iron piping hot. Got a mug of coffee here on the side. And I'm ready to solder all these capacitors back into the places. So I'm just going to kind of speed run through that real fast. Starting with these little boards. Okay, everything's soldered in place. I tried to make them so that they're flush onto the board as possible. And so that one there looks a little, it's just, that one didn't go on so flat there. Might touch that one up a little bit. So everything went fairly smoothly. I'm happy with the way that turned out. Now, unfortunately, I did realize that we have a problem now. Now, do you remember when I said earlier that I kind of struggled removing this board from the main baseboard here, because there was 3 pins here that I didn't realize were soldered to the board still? Well, when I was trying to pull this out, I was using some of these little forceps here, and I noticed that it was like stuck on this side. And so I thought it was that silicone that's down there that you can see there that was holding this from being able to get pulled up. So I latched this onto the board to try to like help me pull it up on that side. What I didn't realize was that the spot where I clamped it, there was a resistor right there, and it looks like I also chewed into that trace right there. So, if I would have put this onto the board without looking at it, I would have like probably ended up damaging something else. The problem is I can't tell if that's 392 or 892. It looks like maybe it's a 3. It looks like that little piece there on the top doesn't touch the or isn't connected to anything. Let's look at it closer. Okay, so looks like that might be a 392. So like that little piece right there doesn't look like it was attached to anything. Down on this side, let's see. Yeah, you can kind of tell there where the paint got pulled up a little bit. Let's see if we can find another 3 something on this board and see if this 3 looks similar. And maybe even an 8 to compare to. There's an 8 right there. Yeah, so that does not look like a 3. That definitely has like a slight, like a more of a sort of like an S shape to it. Yeah, there's an 18D. So yeah, that's not an 8. That's going to be a 3. Although this 3 over here looks different. So, jeez. Just my luck. I had to clamp it onto a spot where there was something there. There's some 3s right there, and those look nothing like that one either. Well, either way, I'm going to have to replace that resistor, fix up that trace, and hopefully I don't end up damaging anything any further. Although it looks like this resistor here is just for controlling the gate of, it's probably a transistor right there. So if it's a 3.9K resistor, that probably makes sense. I really doubt it would be 8.9K. That's getting kind of high for something like that, I believe. So, yeah, that's probably 3.9K. So that's what we'll do. I'll see if I can find a 3.9K resistor, replace it, touch up this trace, and hope that everything's good, because this was all supposed to be basically just a repopulation of capacitors and popping these boards back in. It wasn't supposed to be a repair of any sort. And unfortunately, that's sort of what it turned into. So let's see what we can do. All right, I'm having a really hard time finding a resistor of that exact value. But while I look around here, I'm going to pull this off the board. And I don't like using hot air on this type of material because it tends to start burning easily. And if you saw that little red line on this resistor there, that's or underneath the resistor, it's because it's glued into place. So it makes them a little more difficult to get off the board. So what I'm going to do instead is I just recently got these, well, somewhat recently. It's been a few months now, like hot tweezers. So I'm going to turn this on. And I'm going to use this to try to pull that resistor off the board. And just to make things easier here, I'm just going to put a little bit of flux on that. All right, let's hit it. Where is it? It's right. Can't tell we're both. Okay, there they are. There we go. That was pretty pain-free, so I like that. And while I'm in the area, I'm also going to grind away a little bit of this material here. That way I can solder a jumper wire in between there. It looks like it's still intact in like a portion of it, like right there, but I wouldn't trust this anymore. So I went looking. I do not have any resistors that I can use to replace the one that was on here. And if I would have known that that was damaged, I would have ordered a few while I was in the process of making a list of ordering all the other capacitors that I needed. But like I said, I didn't find out till just now. So I did try to see if maybe there were some boards I had around here that I could like maybe scavenge one from. But I looked at a few and I didn't see anything. So then I thought, well, maybe I have some like through-hole ones. And so I have these, and these are just quarter watt 3.9K resistors, and the colors on that is like orange, white, and red. So I am not about to place an order for just resistors for this thing. And as much as I don't really want to do it like this, I think what I'm going to do is I'm just going to go a little bodge mode here and use this resistor to jump across the points where that resistor would normally be. And the fortunate thing is that this resistor connected between the end of this diode here and the base of this transistor. And I realized that I was calling it a gate, but gate would be if it was a MOSFET. But I actually did look this number up, and it appears that this is a like a version of a 2222 transistor. So I can just put this resistor in that spot right there, and I've already trimmed the leads. And if I can position it right here, you can see that I can solder it into place, like right there. And I mean, that'll work. It's not really doing any different function than the resistor that was on the board there. And then all I have to do is just jump across this one. So that's what I'm going to do. And it'll work. I mean, it should work, assuming nothing else is wrong. So here we go. Let's start off with this side here. And I just realized I didn't unpause OBS to start recording again. But as you can see, I've got it soldered in place now. I just used a little bit of flux. And I put some solder on the end of the tip of the iron. And then I was able to just kind of hold it here with my finger while I touched the solder to those pins there to get them to stick together. And then I did the same thing on this side. And then I just took a trimmed piece of lead from one of the capacitors that I've installed on these boards. And so I got that to stick down. Now I just need to trim this, and looks like I'll probably trim it like around there. Probably should have used some softer wire here. I don't want to lift those traces up if I try to lift on that lead. Yeah, you know what? I'm going to swap this out. I don't like this. I feel like I'm going to pull the traces up if I try to yank that up. Actually, I might just leave it like that. Just have the solder bridge it. Let me see. Try to touch that up a little bit. Yeah, that'll work. I'm just going to leave it like that instead. I'm just going to clean all this off. All right, so there we go. It's not the repair I would have wanted to do, but the one that's going to have to work for now. And I mean, it's not like I'm going to have to open up this thing anytime soon, assuming everything works properly. So this should be good. Okay, so I went through and I double checked everything to make sure that nothing else was damaged, like anywhere that I've meddled. And it looks like everything else is okay. So now it's just a matter of putting these boards back on, applying some power, and seeing if this power supply is going to work. So this one here should be pretty easy to just drop it back in here. Oh, actually, I forgot something. This board here, the one that's down there underneath this heatsink, actually had a little insulator mounted to the back of it, which is definitely going to help now, especially now that I've got that resistor there sticking out the back. So this just goes on like this. It was this way. Yeah, like that. And then it just had these two plastic pins that just snapped into place. Like that. So, yep, that's definitely an extra little safety measure there. And there we go. So, that's now in place. I can solder it in. There we go. That one's done. And that's about how it was when I first removed it. It was kind of angled out this way a little bit. And you can see how those those pins there, if this were to like lean back, it's going to prevent it from like even trying to touch the heatsink. Like that. This one's much easier to do. And now we just need to put in the plug leads here. There we go. That is the Dell power supply completely recapped. And unfortunately also repaired. Or at least I hope. Okay, I've got the board mounted into the case here. I've got one screw in that corner. I've got one screw in this corner. And that's just to prevent the board here from going all shifteroni and like trying to move around. So it's secure, but it's not totally in place there yet. I've got this cable plugged into the back here that is not plugged into the wall. And I was really highly debating on how to do this. I could do like the dim bulb method where, it limits how much current goes into the power supply. And if like something's shorted or whatever, then, it'll just come on. And that way I don't risk burning up anything on the board. But I decided, since this is pretty much the last video that I have planned for the year, I thought we'd give it the full send and see if we go out with victory or if we go out with a bang. So I'm just going to straight up plug the other end of the power cord here straight into mains. And I'm going to use the little power supply tester that I have here on the 24-pin connector. And we'll see if it comes to life. If it does, then I'm going to button it up, put the rest of the screws on, put the case on, and we can pop it into the PC and see if it'll survive with a load. And I'm fairly confident that it should work. I mean, I didn't do anything other than replace the capacitors and then fix the small little bit of damage that I personally did right into that other board, but even that wasn't all that involved. So I think it should be fine, but let's see. Maybe we'll have to cut this video off a little early. So this plugs into there. And just so this thing's not continuously beeping at me, I'm going to plug in the other connectors here that it wants to see. Okay, so I will have to be careful not to be touching around in these areas now once I plug it in, because it is going to be live. All right, here we go. So I'm about to plug it in here. Got to get the cord ready. Okay, here goes. Plugging this in. Okay, in 3, 2, 1. All right. Nothing went explodey on us so far. Let's see what happens. Here we go. All right. It's good. So it's, according to this thing, it's saying we've got 5 volts on the 5 volt, 11.9 on the 12, and 3.3 on the 3.3. So it's, oops, I let go of the switch there. It's looking good. Like I said, I was my fingers crossed there that we weren't going to encounter more issues. So I think it's good. I'll go ahead and put the rest of the screws on, button everything up, and we'll give it a test run in the actual PC. Now the piece of resistance. And done. Okay, so some of you may remember, this is the machine that it came from originally. So I'm going to pop it back in here and hope for the best. I'm not going to bother trying to load an OS or anything like that. I'm just going to make sure that the machine actually comes to life. And if that's all good, then it should be good. Yeah, I'm not going to bother routing this right now. I'm just going to plug it in straight into there. So that's everything that's necessary to get it to power up. All I need now is the power cord, and this is already plugged into mains on the opposite side, so it's going to be live as soon as I plug this in. And on these Dells, as soon as you plug them in, and actually I think it's pretty much like an Intel CPU thing, it's as soon as you plug it in, they usually turn on for like a few seconds and then it'll turn back off. Although, since I was using this as my router, I had it configured to power on after a power loss. So it's probably going to turn on and stay on. Let's see. Assuming the CMOS battery didn't die, which it shouldn't have. It wasn't that old. Let's see. There we go. So you can see that by the fan there that it's on. And if we take a look at the status LEDs in the front, they're doing stuff. So, yep, this power supply is working. Obviously, it's not going to be able to boot or anything, so it's probably going to stop there at some point. Yep, it's working. So, that's good. Definitely happy about that. So, yeah, there we go. Thankfully, I did manage to make things worse for myself, and this is going to be just fine. I'm probably just going to leave this, the original power supply in this machine, and You may have seen the video I did where I bought this other replacement at PSU, but I'm just going to keep this one as a spare. And this one's going to live in here again for now. So I'm definitely happy that things turned out okay with this one. And now for just a little bit of fun, let's just go ahead and see. I mean, we're not going to do them all. Let's just do a few of the smaller capacitors and see what sorts of values they read now. All right, so I just kind of randomly picked 5 out of the bag there of bad caps. And these are the values that I got. I got the 220 microfarad 16 volt, 1000 microfarad 10 volt, 47 microfarad 25 volt, 22 microfarad 16 volt, and 2200 microfarad 16 volt. And I looked up a chart of typical ESR values that we would expect for like these types of capacitors. And these are about the measurements that we should hopefully I mean, we're probably not going to see these, but these are like what we would expect to see with like a good capacitor. And I mean, obviously the lower the better, but if these are like pretty bad, we're going to see what they actually measure. So let's see. Let's start off with the 22016. That's this one. Let me make sure it's all discharged there. Okay. And connecting it now. There we go. So it's measuring 184 microfarad with a ESR of 0.05, so 0.5. So it's a little high, but it's not crazy high. But the capacitance has definitely dropped off. Is that within 20%? Let's see. All right, so calculated to be 20% like under its labeled value, it would be like 176 microfarad. So this is still above a little bit. So like technically it would still be like in range. So this capacitor is not totally bad, but I mean, we did replace it anyway. I'm going to write down the 20% like minus values for the rest of these. So that way we have like a good reference there. So let's see. You know what really grinds my gears, people? Forgetting to hit record. Going on, doing a bunch of stuff and realizing that I captured absolutely none of it. So I went through and I tested all these capacitors, and obviously I talked about it as I was going. Yeah, I have no footage of it whatsoever. So basically, I'm just gonna have to recap here what happened. So I wrote down the values here that we would expect to see, like on the low end of like 20% of the actual labeled value on each of these capacitors. So for this 220, let me zoom in on this. All right, that's better. There you go. So for the 220 microfarad capacitor, that 16 volts, we would expect to see like no lower than about 176 microfarads. For the 1000, 800, 47 microfarad, 37.6, 22, 17.6, and the 2200 2200 microfarad, we'd expect 100 no lower than 1760 microfarads. So I measured the capacitance and ESR of all of these that I had, and for this one here, we got about half ohm of ESR. So this one here, it's not great that it's a little bit higher, but for the actual value that it measures, and that's still within the or that's at the low end of the actually, I just realized I didn't write down what the actual capacitors measured, so should have written that down too. Let me do that real fast. All right, there we go. So for the 220 microfarad capacitor, we got 184.6, which is still above the low end of the 20% there. So this one here is not terrible. It could technically still be like left in service. So that one was fine. The 1000 microfarad, it measured 915 microfarad. So that's still above the minimum of 800. And it had a pretty low ESR, so this one here even that one would have still been okay. The 47 microfarad, this one was pretty unstable, and I actually wrote something down here, but then I erased it because it finally kind of settled down at about 10.8 microfarad. So that's really, really far down from or below a 37.6 minimum, and the resistance on that one measured 1.4K, so that one's definitely bad. Gotta go no matter what. The 22 microfarad, it measured 17 points, or not measured 7, it measured 19.3. The minimum would have been like 17.6. The resistance or ESR did increase almost double. So this one here, I think, yeah, we could have just said let's replace that one. Although it probably wouldn't have been too big of a deal, but yeah, that's what that one ended up being. The 2200 microfarad measured 2080 microfarad, and that's still way above the minimum of 1760. And the ESR on that one was super low. It actually measured 0 on my meter, so that's way below the 0.14. And so that one there is technically, I mean, still a good cap. So I'll probably just throw this in my little bin of like random capacitors, and if I ever need to, like an emergency, pop this into something, like just kind of have it in there. So a lot of times, like these that I'll keep, I just use them for like emergency purposes or whatever, or for when I really just need to test something. So they come in handy for that. And I should probably go through the rest of the capacitors and, see which ones are worth keeping and which ones are not. So, I'll do that later. Not going to worry about it right now. But, yep, that's what we got. And with all of that, that's where we're going to end this one here. I'm happy that things came out working great. And as I was saying, that I was aiming for this video to be like the last one of 2023. And hopefully I'm able to make it in time. And if so, well, I wanted to say have, happy holidays, happy New Year's and all that. And hopefully we'll do a lot more fun stuff in 2024. So I've made it to the end. Thank you all for watching, and I will see you guys around the bench.